Hello everyone. In this section, we are going to learn alternating series definition, and then we will learn alternating test. So let's take a look. Firstly, what's the definition for alternating series? Definition 1. Alternating series means a series has whose terms are alternately positive and negative. So alternating series is a series whose terms are positive and negative. So I'm going to give you several examples and let's see what's the alternating series look like. What's that look like? 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5. So you can see the term is positive, negative, positive, negative, and then plus the general term is -1 to the n plus 1 over n. That's the first example. The second one, -2 plus 1 minus 1/2 plus 1/4. This is also alternating series. Can you see, actually, this is also geometric series. And next, 1 minus 2 plus 3 minus 4 plus 5. General term, -1 to the n plus 1 times n. So for alternating series, we always have a sign in front. You can take a look. Always -1 to the n power or n plus 1 power. So something like this. It's called alternating series. Okay. And next, let's take a look at alternating test. It's given by theorem. Alternating test includes 3 parts. 1, 2, 3. Okay, 1, 2, 3 parts. The first part is if our alternating series look like this, n from 1 to infinity, -1, as we said, we always have -1 to some power in front, right? So here we say -1 to the n plus 1. Doesn't matter too much, okay? We can also say -1 to the n power. So here, and we have un, and what is un in our example? Un is the things left, right? The first condition, all un are positive. The un are all positive. Why do we say that? Because we cannot have un, our series look like -1 to the n power and the sine, cosine thing, like this. Sine, cosine, because they sometimes they are negative values. They have negative value, right? From negative to positive, change from -1 to 1. So in this case, we cannot have this. All the un have to be positive. This is okay, right? Un is 1 or n positive. Second condition, all un term are decreasing eventually. That means when n large enough, non-increasing, all decreasing. That means it cannot be increasing. Let's see, 1 over n is okay because it's decreasing. Okay. The last condition, the limit of un goes to 0. Okay, 3 conditions. Now let's take a look at example. We skip the proof. Okay, we just need to know how to use this theorem to test the alternating series. Example 1. And also alternating series, whenever you see alternating series, we use this test. Because till now, we learned the comparison test. We learned the integral test. Right, those tests. Those tests all work for positive an. An have to be positive. So for alternating, we have negative terms. In this case, we cannot use those two alternating series. That's why for alternating series, we have to use alternating test. Okay. And in the future, we may have other tests, but right now, let's try alternating test. Example, alternating harmonic series. Do you still remember what is harmonic series? Harmonic series is a P series with P equals 1, right? And alternating series means we just add the sign in front. N from 1 to infinity, 1 over n. So look like this. 1 minus 1 half plus 1/3 minus 1/4. Now let's take a look. Is this alternating harmonic series converge or diverge? The first condition, always 3 conditions. The first one, let's pick the un. What is un? Exclude the sign, so it should be this one, right? 1 over n. Is this positive? Yes, because n are natural numbers, all the n are positive. Second one, is the un decreasing? Decreasing, let's see. 1 over n, which is smaller. This is smaller, right? So actually, un is decreasing. Number 3. What's the limit of un? That's the limit of 1 over n. So it is 0. So alternating series satisfy those 3 conditions. And then we say alternating series converges. In the future, we will use this a lot. Okay, it's like a known series. Harmonic is diverges, but alternating harmonic converges. Now let's take a look at the exercise problem. The first one. The second. Okay, I'm going to put the second here. They are all like harmonic alternating series. Okay, now let's take a look at the solution to those 2 problems. The first one, we need to find our un. Okay, and then tell, does un satisfy those 3 conditions? The first one, un positive. Yes, because n positive, 3 to the n is positive. Is this decreasing? Yes, it's decreasing. And what's the limit? Goes to 0. So actually this series converges. Right? The next thing, un, we write down 4 over ln n squared Definitely because we have square thing, even natural log has a negative number, but because we squared it, so it's positive. So first one, un positive. Second, is this decreasing? Natural log function is increasing, right? Natural log is increasing, so 1 over natural log function is decreasing. Third, what's the limit? We know this limit is infinity, so limit n goes to infinity, 4 over ln n squared, this is 0. So we satisfy the three conditions. This theory satisfies these three conditions. Then we say converges. Okay, so we just always use those three conditions to tell alternating series converges or diverges. That's all we need to know for alternating series. Okay, we can stop here.